Okay, so we are going to analyze beam considering support settlement. So this is example 4. We will analyze using stiffness matrix method. Okay, this is the beam. Okay, this beam, ABC, a continuous beam. So EI is not constant. Member AB has 2 EI. Member BC has EI. Okay, AB is loaded with UDL 6 kN per meter. 6 kN per meter along member AB 8 meter length. Okay, member BC is loaded by a vertical load at the center of member BC or element 2, okay, at the center. In addition to that, there is a support settlement. B is settled by 10 mm downward, okay, downward direction. E is 200 GPa and I is 500 times exponent 6, okay, mm4. So okay, we will analyze this. Okay, start by identify or calculate the unknown displacement. After that, use the unknown displacement to calculate the reaction at the support. And after that, we will continue to draw shear force diagram and bending moment diagram. Okay, so actually I have prepared the answer for you. So anyway, I would like to let everyone to check, okay, to check the answer. Okay, to check the answer until the last value lah, the reaction and the diagram. Okay, so to know whether the answer is correct or not is actually by having the right shear force and bending moment diagram, where we get back 0 value at the end of diagram. Okay, so basically by looking at the diagram just now, so B is roller, C is also roller. Okay, B is roller, C is also roller. So by looking at the diagram, we know that at A we have 2 degree of freedom in Y and Z direction. At B we have 1 degree of freedom, and at C we have 1 degree of freedom. So total degree of freedom for unconstrained, okay, unconstrained will be 4. Okay, 4 DOF in unconstrained system, and the remaining will be put in unconstrained. So we have 2 unknown displacement. Okay, to be exact, it is actually represent unknown rotation. Okay, because it is in Z direction. Okay, so we have to label 1, 2. 1, 2, we must label unconstrained first. Okay, we will label unconstrained first. Okay, followed by constraint. Okay, so if in DOF in unconstrained has 2, so we have to label 1, 2, then followed by 3, 4, 5, 6. If in unconstrained system there are 3 DOF, so we have to have 1, 2, 3 in unconstrained, followed by 4, 5, 6 in constraint. So in this case, we have 2 DOF in unconstrained, so we have 1, 2, okay, in unconstrained, and 1, 2 in unconstrained. For displacement, it represents rotation at B and rotation at C. Okay, then only we have unknown reaction. Unknown reaction we label as 3, 4, 5, 6. So means that unknown reaction means Q. So we will have Q3, Q4, Q5, Q6. So Q3, Q4, Q5, Q6. Q3 is actually equivalent to CY. Q4 equivalent to BY, Q5 equivalent to AY, and Q6 equivalent to MA. Okay, MA. Okay, so from the formula, so we will actually calculate the element global stiffness matrices. Element global stiffness matrices, we have AB as element 1 and BC as element 2. So just substitute into the formula, so we get this value. Okay, so don't forget to include 2 EI for K1 and only EI for K2. So we get all the value in the matrix. And what most important is the label. So label ni important lah. Label we must refer to near condition, near to far, and near condition to far condition, near to far. So for element number 1 we have 5, 6. For element number 1 we have 5, 6. Okay, 5, 6, 4, 1. We have 5, 6, 4, 1. So we should label 5, 6, 4, 1 for element number 1. And for element number 2, we have, okay, element number 2 we have 4, 1, 3, 2. 4, 1, 3, 2. So we get like this. Okay, so I believe this part everybody understand. Okay, so don't forget to label the degree of freedom, because without labeling we cannot we cannot identify the stiffness matrix for the beam. Okay, K, the capital K. So capital K, so all degree of freedom means the position in the capital K in the structure stiffness matrix. Okay, so label ni important 5, 6, 4, 1 and 4, 1, 3, 2. Anyway, it will be depending on how you label your diagram. Okay, so from this we will get the structure stiffness matrix. This is the structure stiffness matrix. Okay, we have to put EI. Okay, and we have 6 by 6 matrix, because total nodes in this example is 3. So 3 times 2 equivalent to 6. So we have 6 by 6. So we have to know the position. So the position, for example, if you want to know position 3, 4. So where is 3, 4? 3, 4 is this. Okay, position 2, 5, 5, 2. 2, 5 we have this. 2, 5, 5, 2 is the same. If we want to have the value at position 4, 6 or 6, 4. 4, 6, 6, 4 will be the same because it is symmetry matrix. 4, 6, 6, 4 is the same. This is the value for 4, 6. Okay, so all this value we get from K1 and K2. So 0 value means we cannot, we don't have the value, okay, in K1 and K2. Okay, means no intersection. No intersection means no value. Okay, so we have like this. So saya dah semak actually exercise formative 2.2 yang you dah submit. So this part consider okay. Cuma ada jugalah yang still label tak kena. Okay, tapi basically 90% tu dah okay lah for identification or establishing this structure stiffness matrix. Okay, so we move to step number 4. Step number 4 is actually for nodal forces and nodal displacement. Nodal forces and nodal displacement. Why we need to have this? Because we want to establish, we want to calculate unknown reaction. And to calculate unknown reaction, we have to consider equation or the relation between Q and relation between D. Because Q and D ni, okay, this is relation between forces and displacement, and from this we get Q is equal to KD. Okay, so K is actually stiffness coefficient. I have explained to you if we transform this into graph. So this is Q, this is displacement. So this one is K. Kecerunan is K. Okay, so to get K is equivalent to Q divided by D. So that's why we get Q is equal to KD. That's why we get the relationship. So relationship basically we get from graph. Okay, so it is Q is equal to KD. It is stiffness equation, or we also call as force displacement equation. So we should write or establish Q and D in matrix form as well. Okay, matrix form as well. So if there are 6 degrees of freedom, means we will have Q from Q1 until Q6, and D also we have D1 until D6. Okay, except under this, okay, we have the boundary. So boundary here at 2 lah, okay, at position 2 because 1 and 2 under unconstrained system and 3, 4, 5, 6 under constrained system. So this will be the same. Okay, so means that D1 and D2. So we have to know that D1 and D2 we have to remain as unknown because this D1 and D2 will be the value that we need to calculate. So the rest, okay, by looking at this question, so dia ada kat sini. Delta B is equal to -10. Okay, delta B is equal to -10. Okay, so delta B ni means that dekat B, at B ni we have delta B, we have theta B. Okay, at C we have delta C, we have theta C. Okay, at A we have delta A and theta A. Okay. Okay, theta B and theta C is actually the unknown. This is D1 and D2. Okay, D1 and D2. So we have 4, okay, 3, 4, 5, 6. Okay, delta A is actually delta A. Delta A numbering apa? What is the number representing deflection at A? 3, 4, 5, 6 tu. Yang ni. 3, 4, 5, 6. We have D3, D4, D5, D6. Apa yang dalam D ni, D3, D4, D5, D6 ni, yang mana represent delta A? Kita tengok pada ni. Representing delta A. 5 or 6? We have 5, we have 6. Is it 6 or 5? 6 or 5?
6 theta.
6 theta, right? Okay, 6 theta. So 6 tu is actually theta. Sorry. This is D6. This is D6. Okay, so D5 is actually delta A. D5. D5 is actually delta A. Okay, what about B? What about B? Okay, we have to represent delta B. Okay, between 4 and 1, which one? Between 4 and 1, which one represent? Between D1 and D4, which one represent delta B?
4.
4. D4, D4. Okay, between delta C, between 3 and 2, D3 and D2, which one represent delta C? Which one? 3 or 2?
3.
Delta C 3.
3. Okay, yes, correct. It is 3. So D3. Okay, D3. So delta B is D1. So yang ni D1. This is D1. This is D2. Okay, so it is actually this. Okay, beam. Okay, beam, deflect. So sini fix, sini roller. Okay, deflect. Okay, deflect like this. So in this case, the delta at B, this is delta at C, this is delta at A is equal to 0, delta at B, not delta, theta. Theta at A is equal to 0. Okay, without settlement, this is 0, this is also 0. Okay, this 4, 0 represent, okay, normal condition represent D 3, D4, D5, D6. So yang ni yang bila kita tulis dalam matrix tu kan, kita akan tulis macam ni. 0, 0, 0, 0. 3, 4, 5, 6. Okay, now at B, dia bagi dekat B ni ada negative 10 mm. Negative 10 mm at B. Okay, so B ni, okay, at B, kita punya label tadi tu dekat B, tadi kan kita ada yang ni. Okay, kita ada 4, 1 sini. 4, 1. Okay, so means that this is equivalent to D4. D4 means that dekat 4 ni, kita tak boleh lagi letak 0. Kita kena letak dia negatif 0.01. Kita gantikan displacement yang 0 tadi dengan nilai displacement, nilai settlement. Okay, before this without settlement, value dia 0. That's why kita put 0 kat situ. Now, because of settlement, because of support settlement at position B, we have label S4. Okay, so D4 representing delta B, so we have to put at position 4 the value is negative 0.01 macam ni. Okay, that is why kita dapat dekat sini negative, okay, negative 0.01. The rest maintain 0, 0, 0. Okay, yang lain maintain 0. Okay, D1, D2 maintain as unknown displacement. Okay, D3 0 because D3 represent delta at C, no settlement. Okay, lepas tu D4 represent delta at B ada settlement. Lepas tu 5, D5 is for delta at A, no settlement. And theta at A, D6 is theta at A, no rotation. So all 0 except position number 4. So support settlement, we have to include, okay, include the settlement at this step. Step ni yang kita kena masukkan settlement, step ni. Okay, Q tak berubah, Q masih lagi remain, okay, macam ni, macam before this kan. Before this, Q1 until Q6, so Q1 and Q2 tu tengok pada beam, tengok pada beam. 1 representing what? So Q and D ni dia represent different things lah. Q akan represent forces, D akan represent deflection and rotation. Okay, whether dia deflection or whether dia rotation, dia akan depend pada degree of freedom. Sama juga dengan Q. Q akan represent two things dalam ni. Dia akan represent either moment, okay, moment or vertical reaction or vertical forces. Okay, vertical forces. So kita tengok pada position. So position 1, Q1 represent moment. Sebab 1 kita ni, label 1 representing ni, label 1 for moment because 1 tu Z direction. Z represent moment. 2 also represent moment. Jadi at position 1, tengok pada B, ada tak moment dekat B? Kalau ada moment dekat B, kita akan letak nilai moment tu. Okay, without any moment dekat B, so kita letak 0. That's why we get 0 at position 1 for Q. Sama juga dengan C. At C tu kita tengok number 2 kan, kita punya Q2 ni. Maksudnya Q2 kalau ada moment dekat sini dia akan masuk. Tapi kalau tak ada moment, so dia akan jadi 0. So the rest 3, 4, 5, 6 are the unknown reaction. So maintain as symbol first. Okay, so yang ni dah settle. So we move to equivalent nodal forces. Equivalent nodal forces, and to calculate equivalent nodal forces, we have to identify first or establish first equivalent element nodal forces. Equivalent element, the word element itself, okay, kalau K kita ada K1 and K2. K1 and K2 is equivalent to capital K. So small letter we use for element, capital letter we use for structure. Jadi for equivalent nodal forces, we have equivalent element. So equivalent element we use symbol Q1 node plus Q2 node. Okay, Q node to symbol for equivalent nodal forces. 1 and 2 represent element. So we get Q node macam ni. Okay, so yang ni, ini dia simbol dia ni. So nota yang high tu saya lupa letak node. Saya letak 1 and 2 only. Okay, tapi doesn't matter. The most important thing you faham step tu. Okay, so kita akan apply back the label. Okay, the same label. So 5641. Okay, for Q1 node, so we label it here. And for Q2 node, 4132. 4132. So ramai yang betul buat yang ni untuk yang formative 2.2. Actually lebih kurang sama je. Okay, cuma ada juga 1-2 orang yang saya jumpa dia include sekali yang yang point load tu, point load or moment at joint tu jangan So yang ni equivalent element nodal forces ni just for member yang di atas dia ada force. Okay, member bukan joint. So kalau yang joint hujung dekat B ada point load atau ada moment situ tak masuk dalam equivalent nodal forces sebab dia dah masuk dalam Q. So equivalent element nodal forces we only calculate the value whenever member has loaded. Okay, by loading lah UDL or point load on the member. Macam case AB ni ada UDL subjected on the member. Member cannot carry load, so we have to distribute to the nodes. And using stiffness method, we only calculate forces and displacement at nodes. So we have to distribute it to the nodes. So we call it as equivalent element nodal forces. Okay, so yang ni saya dah guide hari tu dalam previous dalam formative 2.2 dan dalam example 2, example before this. Okay, ni saya cepatkan lah. Okay, so we get like this we get like this. So make sure label this label is correct. So we get yang ni lah. Okay, we get yang ni. So yang ni jangan pergi tambah, kalau ada moment kat sini semua jangan tambah Tak boleh tambah sebab moment dekat B or moment dekat C dia dah masuk dekat Q, bukan Q naught. So kita dapat kat sini Q naught yang ni. Okay, yang ni dah dapat settle. So kita masuk dalam stiffness equation. So once we get this stiffness equation, kita ada kat sini 0.01, negative 0.01. So dekat sini, macam mana nak solve? This is only mathematical solution. Macam mana nak solve matrix? Okay, matrix, this is 6x6 matrix. Okay, 6x6 matrix. When we want to solve for unknown displacement, apa yang kita buat actually, kita akan buat macam ni, the process. Okay, it is line 1 kali dengan yang ni. Is it right? When we want to calculate value for line number 2, yang ni, kita kali dengan yang ni. Kan? You remember the matrix multiplication? Okay, line number 3 pun kita kali dengan yang ni. Okay, line number 4 kali dengan yang ni. Line number 5 pun kali dengan yang ni. Line number 6 pun kali dengan yang ni. So, bila kita kali dengan D tu, okay, before this, whenever semua ni 0, so all this value bila kali dengan 0, yang ni semua ni, all this value bila kali dengan 0, we get 0. That's why in the previous example, okay, I ada statement. I have put one statement, okay, mentioning about, okay, consider only unconstrained system. Okay, consider only unconstrained system tu hanya valid kalau tak ada settlement. Because bila ada settlement, of course kita kena consider yang ni. Position 4, position 4. So in order to solve for this is mathematics ya, ni bukan structure. Okay, so because yang 3 ni 0.094 dia kali dengan 0. Dia kali dengan 0, that's why dia 0. But okay, at position 4 we have negative 0.094 kali dengan negative 0.01. Okay, 0.01. Okay, jangan tanya kenapa macam ni sebab ni matematik. Okay, kali dengan 0.01. That's why saya tulis kat sini macam ni. And we have 0.094 yang ni. 0.094 kali juga dengan yang ni. Ini prinsip matematik. Okay, so we have additional this. Okay, for support settlement. Support settlement. Okay, for support settlement. Barulah kita tambah dengan 8 dan negative 40. Okay, 8 and negative 40. So this value kita solve, we will get this negative 94 and 94. Okay, this value we have to add. So we get yang ni. 86 dengan negatif 54. Okay, 86 dengan negatif 54. So we get, ini check jawapan Jawapan ni you must check back. Okay, we get D1 and D2 as 0.821 exponent negative 3 and negative 1.491 exponent negative 3. Okay, you need to check back. Okay, so after that we have to calculate reaction. We have to calculate unknown reaction. So yang ni pun kena include juga yang 4 ni. Sebab 4 ni dia ada value. Okay, include juga yang 4 ni. Yang ni saya buat, saya simplify jadi bentuk ni. So dia masih lagi 6 kali 6 ni. 6 kali 6 kali dengan 6 kali 1. That's why kita dapat 6 kali 1 punya matrix. Okay, kita dapat yang ni. This is the value that we get. Okay, the value that we get, then kita tambah dengan yang ni. So yang ni matematik juga. Okay, kalau you tak nampak in this format, you kena tulis in full 6 kali 6. Okay, so yang ni saya tulis yang mana yang ada value. Yang mana yang zero value saya dah skip. Okay, so we have 0.094 ni kali dengan yang ni. 0.000821 plus dengan nombor 2 pula, negatif 0.094 kali dengan negatif 0.00149. Sebab position dia sama, 2 dengan 2. Okey, lepas tu plus lagi dengan negatif 0.023 kali dengan negatif 0.01 kali dengan EI plus dengan 20. Dapat 49.29. Nanti check balik. Okey, 49.29. Okey. Okay, we do the same for Q4. We do the same for Q4. So for Q4, if you want to calculate Q4, it is negative 0.094 kali dengan position dia position 1 kali dengan 1 plus position dia position 2 kali dengan 2 kat sini. Then plus lagi position dia position 4 kali dengan 4 kat sini. This is mathematics. Multiplication in matrix. Okay, so we get plus dengan 44. Plus dengan 44, we get negative 47.72. Negative 47.772. Okay. Same goes to Q5 and Q6. Okay, cuba tengok tekan kalkulator. Cuba you tekan kalkulator Q5. Q5, yang ni kali dengan yang ni. Plus, yang ni 0 dah boleh skip. Yang ni kali dengan 0.01 negatif. Then, because it is 5, kita tambah 5 ni. Okay, 24. Cuba check, dapat tak yang ni? Cuba check kejap. Okay, get familiar dengan proses ni. Sebab proses ni proses matematik biasa yang you dah pernah buat actually masa belajar matrix. Okay, masa belajar matrix. Cuma apa yang saya tulis kat sini, as I mentioned just now, saya simplify. So that saya tak perlu tulis sampai 6 kali 6. So saya hanya tulis dekat sini apa yang akan bagi kita value. Okay, that's why saya simplify like this. So dalam buku pun ada contoh yang dia simplify macam ni. Tapi it is actually samalah penuh 6 by 6 matrix. Okay, because we want to consider only Q, kita nak cari Q at position 3, 4, 5, 6. So yang ini kita nak kena consider yang ni je lah. 3, 4, 5, 6. Okay, 3, 4, 5, 6. Sebab yang ni kita nak cari 3, 4, 5, 6. Okay, boleh tak get familiar dengan proses ni? This is very very important. Because whenever dah masuk stage nak solve ni, okay, reaction, considering support settlement, so kena consider juga pada position yang ada settlement. Okey, ada satu example dalam buku teks Hibler, under trust pun ada satu example yang buat support settlement. Dalam textbook ada. Okey, dapat tak? Kena praktis ya untuk solve benda ni. This is very very important how we analyze.
Doktor.
Ya.
Yang tadi tu kira macam mana? 0.188 darab dengan 0.000821 tu.
Yalah dia matrix kan? Dia kali kan kita belajar matrix dulu. Contoh kan kita belajar matrix 2 3 4 5. Kan? Kali dengan A and B. Macam mana kita kali matrix tu?
2 darab A.
2A tambah 3B kan? So sama lah yang tu. Cuma yang ni. So yang ni sama. Yang ni kalau contoh 2, 3, 4, 5, 6, 7. Kan? Yang ni. Kan? Kali dengan A, B, C. Kalau yang ni macam mana? 2
darab A.
2 darab A tambah
3 darab
3B tambah
4C.
4C. So sama yang atas tu. Kita kali ikut position. So position dia 1, 2, 3. 1, 2, 4 yang ni. 1, 2, 4 kan? 1, 2, 4. Sini pun 1, 2, 4. Proses dia sama. Okay, so 1 ni kena kali dengan 1. 2 ni kena kali dengan 2 kena kali dengan 2. Lepas tu 3 bukan 3, 4 kena kali dengan 4. Actually dia ada 3 kali dengan 3, 5 kali dengan 5, 6 kali dengan 6 position tu. Tapi 3 kali dengan 3 sebab kali 0, displacement 0. That's why yang tu dapat 0, so saya tak masukkan dalam ni. Sama juga 5. So dia ada 5 kan, 5, value 5 tu kat sini. So dia kat sini kan dalam ni. Dia asal yang ni. Yang ni. Kita nak solvekan yang ni. Q3, Q4, Q5, Q6. Q3, Q4, Q5, Q6. Kita nak cari nilai tu yang kita buat line by line. Kita buat settle dulu Q3, lepas tu dah settle Q3 baru buat Q4, Q5, Q6. So whenever kita nak calculate Q3, apa kita buat? Kita consider semua value ni kali dengan semua value ni. Betul tak? So nilai kat sini, nilai dekat sini 3 kan, negatif 0.094 dengan negatif 0.094. Yang ni nilai dia. Okay. So whenever we want to calculate ni Q3 apa kita buat? Kali dengan semua kali dengan ni. Sebab dia 1 kali dengan 1, 2 kali dengan 2, 3 kali dengan 3. Kan? Matrix kan? Okay, jadi untuk calculate Q3 apa kita buat? In full, it is negative 0.094 kali dengan D1. Kan? Lepas tu plus lagi, plus negatif lah kan? Negatif 0.094 kali dengan D2. Kan? Lepas tu plus lagi 0. Yang ni pula 0.023 kali dengan apa? 0 kan? Nampak tak? 0.
Nampak.
Lepas tu tambah lagi. Tambah, sini tolak kan? Sini tolak tambah. Okey, kita buat positif lah. So it is 0.023 kali dengan 0.01. Yang tu 44. Sekarang continue dengan 55. 55 we have 0 times 0. Sini 0, sini pun 0. Kan? Tambah lagi yang ni 0, 0. Yang tu untuk Q3. So bila kita cancel yang 0 ni, cancel 0 ni, cancel 0 ni, cancel 0 ni. Sama tak dengan yang saya tulis tadi? Sama tak dengan saya tulis ni? The process. Sama tak?
Sama.
Okay. So sama ada you nak tulis dia macam ni atau you nak terus tulis dia macam ni, it's up to you. Macam ni. Macam ni As long as dapat Q3. Because kita punya target dah dapat Q3. Okay, kita punya target dah dapat Q3. So this is the process. This is in matrix form. Okay, yang saya tulis tu, saya simplify matrix 6 by 6 tu. Okay, saya buang yang 0. So tinggal yang ni. So yang ni yang akan contribute pada value, pada Q3, Q4, Q5, Q6. Okay, cuba tulis Q4 punya equation. Q4 from yang atas ni. Nanti kita compare. Cuba tengok Q4. Now consider Q4. So bila nak calculate value for Q4, kita akan consider Q4 ni kan. Kita akan consider value ni. Ini 4 kan. Q4 kali dengan yang ni. Baru tambah dengan 4 ni. Okay. So nilai kat situ 4, nampak tak? Kita ambil balik nilai sini. Ni 41 sama dengan 14. 14 is negative 0.094. Okay. Sini value dia this is 42. 42 sama dengan 24. 0.094. Lepas tu 43. 43 sama dengan ni 43 kan. 43 sama dengan 34. 34 we have negative 0.023. Okay, 34 sama dengan 43. 34 mana? 34 ni. So sama dengan nilai 43. Okay, ni 43. Okay, so all nilai ni semua ni, all these 6 value. Okay, yang saya highlight ni. Kejap. Bukan. Mana dia highlighter? Saya tak create highlighter pula. Tak apa. Okay, yang ni yang saya highlight kuning ni. Kan, yang saya highlight kuning tu. Okay, it is negative 0.094, 0.094, negative 0.023, 0.070, negative 0.047, and negative 0.188. Kan position dia tu kan 41, 42, 43, 44, 45, 46. Okay, so what is the equation untuk dapatkan Q4 tu? Apa dia? Q4. Apa Q4? Jangan lupa EI lah. EI nanti calculate last kali. Okay, kali last kali. Okay, Q4 equal to?
Negative 0.094.
0.094
times D1.
D1. Okay, lepas tu?
Plus 0.094 times D2.
Okay. Lagi?
Plus negative 0.023 times 0.
So, yang ni saya terus tukar jadi negatif So, negatif 0.023 times 0 kan?
Yes.
Okay, lagi?
Plus 0.070
Okay,
times
plus
dengan negative 0.01.
Negative 0.01. Okay, lagi?
Plus with negative 0.047 times 0.
Okay, plus negative. Okay, plus negative 0.047 kali?
0.
Kali 0 lagi?
Plus with negative 0.188 times 0.
Okay, times 0. So, semua ni kena kali dengan EI EI jangan lupa EI. Semua kena kali dengan EI. Plus dengan ni. Plus dengan 44. plus dengan 44. Barulah kita dapat Q4. Nampak tak yang ni? So yang ada value, okay, kalau kita cancelkan all zero kat sini, okay, kita cancel all zero kat sini, so yang ni cancel jadi 0. Okay, so yang ni pun cancel jadi 0. Yang ni pun cancel 0. Sama tak dengan yang ni? Q4 tadi kan? Q4 ni. Sama tak dengan ni? Sama kan? Tambahkan ni. So yang ni semua matematik je. Okay, so you kena familiar balik dengan proses tu. Okay, so kalau you faham konsep matrix tu, insyaAllah you boleh buat yang ni. Okay, so kena fahamlah beza whenever we have support settlement, kat mana kita nak include. Okay, so proses tu sama sampai habis lah. Kita akan include pada, so yang ni nanti kita try buat balik. Kita try buat balik sambil-sambil check jawapan lah. Ini yang saya dah buat. Okay, macam tadilah. So kat mana kita include displacement. That's why you kena faham yang free body diagram ni. You kena faham setiap label yang kita nak numbering tu, degree of freedom yang kita label 1 until 6 tu. Okay, 1 sampai 6, D1 sampai D6, Q1 sampai Q6 tu dia represent apa. Kalau you masih nampak dia as number, you tak nampak dia by diagram, you takkan boleh letak kat mana position, the correct position bila settlement given in the question. So whenever you dah faham benda tu, baru you boleh letak dekat the correct position. Sebab everybody akan ada possibility untuk have different label for settlement tu. Sebab ada orang label dekat B ni 4, sini kita label 4, ada orang lain dia label 5. Ada orang lain dia label 6. Kan, ada orang lain mungkin dia label 5, dia label 3. So it depend on how you label. So kat mana position yang you label tu, kat situ yang kita kena letak. So kalau you label 3, kena letak dekat 3. In this case, saya label 4. So 4, D4 represent deflection at B. Deflection at B. That's why nilai 0.01 downward tu saya letak dekat 4. Okay. So bila dah include 4 dalam ni, you kena tahu macam mana nak consider this. Okay, this D4 yang ada value, yang before this 0, now ada value. Macam mana nak include dalam, okay, dalam stiffness equation tu, kita dah masukkan, macam mana nak solve. Okay, macam mana nak solve. Yang lain-lain semua sama. Okay, ni semua sama, step yang sama. Except masa nak solve benda ni. Yang ni, bila nak solve. This is the same process. Okay, the same process. Macam mana nak dapatkan nilai ni. Okay, proses dia adalah kat sini. Kan, whenever we want to solve for displacement, kita akan ambil position ni kali dengan yang ni. So, negative 0.094 kali dengan negative 0.01, kita dapat kali dengan EI, dapat satu value, tambah dengan 8. Okay, sama juga yang bawah tu. Yang bawah ni 0.094 EI. EI kali dengan negative 0.01 baru tambah dengan negative 40. So kita dapat kat sini negative 40. Bukan negative 40. Tambah negative 40 ni kita dapat value kat sini. So kita dapatlah negative 54. So check back all the answer that I have put. Okay. So bila go to the diagram, so dah siap semua kan? Dah siap semua. Okay, bila kita draw diagram, normally dia patut dapat 0 dekat sini. But because of decimal places that we take, sometimes kita dapat value. Okay, value. Doesn't matter lah kalau due to decimal places, kita assume dia je 0. Kan 0.0 something, or kita dapat 1 ke kan. Okay, because of decimal places. So lagi banyak kita consider decimal places tu, kita akan dapat lagi accurate lah. Okay. So yang ni bentuk dia pun tak beza banyak dengan previous example dan juga formative 2.2. Okay, formative 2.2 tak jauh beza. So kita dapat moment dekat sini. So moment, this is moment, this is vertical force ni shear value. This is shear value, ni shear value. Yang ni 6 kali 8 shear value juga. Okay, so to draw the shear force diagram, we consider all the shear value. Okay, start dengan 0. So diagram we draw start from 0. So 0 we plus the first value 86.43, we get this value, this point. So sampai this point kita akan minus dengan 6 kali 8. 6 kali 8 meter kita dapat 48. Minus we get 38.43. 38.43 dia jumpa pula 47 ke bawah. So kita minuskan dengan 47.72, terdapat point dekat sini. Okay, it is 9.29. 9.29 go straight sampai dekat sini, jumpa lagi 40. Okay, turun lagi 40, we get 49.29. Okay, go straight sampai jumpa yang ni, kita dapat kat sini, yang ni positif pula, tadi negatif kan, tambah, kita akan end the diagram at 0. So memang kita akan dapat 1 negatif. So tambah dengan yang ni, so kita akan dapat 0. So diagram kita akan close at 0. Start at 0, dia punya flow dia macam ni. Start kat sini, naik atas ni, pergi sini, pergi sini, pergi sini, pergi sini, pergi sini, naik atas balik, close. Baru complete kita punya diagram. Okay, so all the, okay, ini apa bentuk-bentuk ni kan. Okay, trapezium, we get trapezium, we get kat sini petak ni kan. Okay, rectangular kan. So the area of this, the area of shear force is, the shear force diagram is bending moment. Okay, so bending moment, bila kita nak draw bending moment diagram, kita akan tengok pada diagram the first value of moment. Ini dia first value. Okay, first value. Tapi jangan lupa kita start from 0. So start dia dekat 0. Bila kita start dekat 0, kita tengok value ni, dia minus. By diagram, dia minus. So, dia duduk dekat negatif lah. Negatif 261.05. Lepas tu, tambahkan dengan area of trapezium. Area of trapezium. Area of trapezium ni ada meaning. Kalau dia ada intersection, bila kita draw shear force diagram, kalau kita dapat macam ni, ini makna dia kita dapat maximum moment pada bending moment diagram. Okay, but when we have trapezium like this, we don't have the maximum moment kat dalam, kat tengah ni, no intersection. So dia macam ni je, curve macam ni je. So point dapat dari mana? Tambah. So negative 261 ni, yang ni saya tak letak negatif because dia duduk dekat area negatif. So it is actually negative 261.05 plus the area of trapezium. Okay, plus the area of trapezium, we get yang ni, 238.39. Okay, check back the value. Okay, lepas tu kita ada area yang kecil ni. Area yang kecil ni, it is 4 times 9.29. 4 times 9.29, value, last value tadi ni, 238.39. We have to minus sebab dia duduk kat bawah line 0. Minus area of yang tadi itulah 4 times 9.29. We get this value. Value dia masih positif. So point dia dekat sini. Okay, point dia dekat sini. And then minus area yang last tu. Area yang last is 49.29 times 4. Length sini 4. Times 4. So we should get 0 lah. Sometimes ada ralat kat sini, as I mentioned, ralat tu because of decimal places. So the concept is like this. Okay. So try to understand this because this is very very important. And ramai juga yang tak buat diagram ni masa submit formative assessment. Okay, so buat betul-betul. Buat, make sure you faham because you need that understanding untuk jawab test. Okay, sebab saya tahu ada yang salin je. Sebab ada jawapan kat atas, step kat atas tu salah tapi jawapan di akhir je betul. Okay, and bila solve stiffness matrix, displacement tu, unknown displacement, tolong letak unit. Okay, because that is one of the output. Lepas tu bila dapat reaction at the support, Q tu pun kena letak unit, and careful dengan unit tu because ada moment, kena letak unit moment, ada kilonewton kan, force, vertical force yang kena letak unit kilonewton. So yang tu pun kena letak unit. Sebab reaction at the support tu is also another output. So output ni kena letak unit. So lepas tu nak check whether what you calculate is correct or not, you kena draw diagram. And this diagram is very very important for you to understand because bending moment ni macam saya ada tunjuk, saya ada share kan some notes about the bending moment ni kan. So bending moment is very important to identify crack pattern. Nanti nak design, nak kena tengok the accurate shape of beam, kita kena tengok based on bending moment diagram. So this is very important. You tak boleh skip benda ni. Okay, you must learn until you understand how to draw the shear force and bending moment diagram. So yang mana yang tak lengkapkan bending moment diagram tu, please lengkapkan bending moment diagram sampai bending moment diagram. Yang mana-mana yang ada buat mistake tu, yang saya kata ada salah lah, yang mana yang ada salah saya dah komen. Okay, tolong buat correction. Okay, because stiffness method ni dia punya test ke exam ke sama je soalan. Tukar diagram je, tukar value. This is exactly the test. The test question, the exam question, this is exactly the same. Kalau you tak gunakan peluang untuk buat benda ni betul-betul, so memang rugilah. Okay? So nanti tengok balik. So saya actually dah buat juga kat sini the full answer for saya dah buat full answer. Okay, for formative 2.2 ada dekat example 3 ni. Ada dekat example 3 ni. This is formative 2.2. Okay, 2.2. So nanti saya akan assign this to you in your student folder tu dalam OneNote. Okay. So you gunakan this note untuk study lah sampai faham. Okay, sampai faham. So make sure you jangan silap dekat part Q tu, jangan mix dengan Q note. Memang ada version lain untuk solve ni. Ada buku yang dia bawa version lain. Okay, actually tak ada masalah you nak follow version apa pun, tapi mesti betul-betul faham. Okay, sebab bila you follow separuh-separuh, nanti you start confused. So ada yang saya jumpa yang dia follow another version, betul, doesn't matter. Ada yang follow tapi salah. Ada yang dia tengok separuh-separuh. Dia buat yang tu separuh, dia buat yang ni separuh. Lala salah. Okay, so try to, kalau boleh fokus satu method. Bukan method, satu style lah kan. Yang ni style yang saya tunjuk ni, this is the simplest. Okay, kalau you follow betul-betul kan. So insyaAllah, you follow the step. Okay, you redo several times, insyaAllah you akan faham dan memang boleh score. So this is the topic where you can score your score test tu. So student-student biasanya exam pun dia akan score dekat stiffness method compared to other method. Sebab yang ni formula given, procedure tu sama. So dia tak boleh nak twist soalan pun. Soalan dia memang macam tu lah setiap semester. Okay, so you just have to buat few times sampai faham. So try to buat dengan kefahaman, bukan salin je. Okay, so check balik. So saya ada komen dekat assessment tu, sebahagian lah, ada lagi yang belum. Okay, tengok balik my comment tu, yang mana yang salah tu, buat correction lah. Okay, for your future reference. Okay, so kita akan tak close lagi, kita nak buat satu pop quiz. Okay, kejap So for this, okay, we end dekat sini for example 4 tadi tu, considering support settlement. Okay, yang ni nanti saya akan bagi later, saya akan distribute these notes. So kita nak move to, okay, yang ini. So move to this. Okay, this is the code this is the code, this is the QR code. Okay, boleh scan. Okay, I want you to put your matrix number. Bukan nama matrix number. Okay, please put your matrix number. Okay, because saya akan tick your attendance based on your participation on this quiz. Okay, please put your matrix number, bukannya nama Okey, 18 ya. Okay, I will stop this screen sharing. You fokus dekat screen yang mana class point ni appear, yang mana yang pakai handphone. Okay, refer to this screen, class point screen. Yang mana yang pakai laptop, refer pada screen ni jugalah. Okay, so saya akan stop this. Okay, so you listen to my instruction lah. Okay, nampak kan soalan? Okay, nampak soalan kan? So actually all this question actually I took from notes that I have shared in the general channel. Okay, so, semua ni terdapat bila kita Google. Okay, that's why saya selalu cakap ada soalan yang you rasa macam nak cari jawapan, you search je kat Google tu kan. So ada macam-macam jawapan kat situ. Okay, so this is the first statement, choose yes or no. A beam is a structure element that primarily resists load applied laterally to the beam's axis. Its modes of deflection is primarily by bending. The load applied to the beam result in reaction forces at the beam support points. The total effect of all the forces acting on the beam is to produce shear forces and bending moment within the beam that in turn induce internal stresses, strain and deflection of the beam. Beam are characterized by their manner of support, profile, shape of cross-section, equilibrium condition, length and their material. Okay, choose yes or no. Okay, we move to question number 2 first. Okay, this is number 2. So try to understand the statement carefully. Choose yes or no. Beams undergo compression in the bottom and tension at the top. The top steel is also known as anchor bar and it is used to anchor stirrup, which would otherwise would not be placed in the position required. In cantilever beam, however, compression is at top and tension at bottom. Okay, yes or no? Okay, you have 3 minutes. Masih sempat lagi nak buka general channel untuk baca dulu sebelum choose jawapan. Okay, you have 2.5 minutes. Okay, another 30 minutes. Ada lagi yang belum jawab, lagi 3 orang belum jawab ya. Okay, we move to the next question. Okay, bending moment is important in civil engineering because bending moment is important in civil engineering because we have 4 answers, so you may have more than 1 answer. Okay, actually there is 1 answer. No, there are 3 answers in this question. 1 is not the answer. Okay, you have to choose 3 right answer representing the bending moment, the importance of bending moment in civil engineering. Okay, choose 3 answer. Okay, choose 3 answer. We have A, we proportion structural element based on its magnitude, especially beam element. Okay, B, beam is the horizontal member subjected to bending moment only. C, it plays a major role in the amount of reinforcement to be placed in any reinforced concrete structures. D. Beams undergo tension in the bottom and compression at top determined from bending moment diagram. Okay, so choose 3 right answer. Okay. Okay, we move to the next question. Choose one wrong answer. Choose one wrong answer. Indeterminate structure are more applicable than determinate structure. Okay, we want to look at the advantages of indeterminate structures. Okay, A, the maximum stresses in statically indeterminate structures are generally lower than those in comparable determinate structures. Indeterminate structures have more members and reactions than required for static stability. So if a part or member or support of such a structure fails, the entire structure will not necessarily collapse and the load will be redistributed to the adjacent portions of the structure. Okay? And then C, statically indeterminate structures generally have higher stiffnesses, so smaller deformation than those comparable determinate structures. D, support settlement do not cause any stresses in indeterminate structures. Okay, choose one wrong statement. Okay, choose one wrong statement. Okay, about 50 minutes. So 85, 852, 87. Belum lagi 862, 88, 16 lagi. Belum cukup. Okay, another 30 second. Okay. Okay, let's look at the last question. Okay, the last question. In real structures, a cantilever beam are. Okay, there are 4 answers. Choose 4 right answer. Okay, A, balanced cantilever bridges. B, roof canopy. C, single span bridge. D, staircase where the landing is not supported. E, balcony. F, precast beams and slab. Okay, jawapan dia ada dekat general channel. Okay, just choose 4 right answer. Okay, question number 1, the right answer is A. Question number 2, the right answer is B. Okay, because beam undergo tension in bottom. Terbalik statement ni. Okay, yang ni the answer is, okay, the answer are A, C and D. Because yang B tu, okay, the right statement is beam is the horizontal member subjected to shear force and bending moment. Okay, this, okay, the answer is D. Okay, because support settlement do not cause any stresses in determinate beam. Okay, in terms of support settlement, okay, determinate structure yang ada advantage. Okay, yang ABC tu correct lah, correct is the correct statement for indeterminate structure, but D tu is not the correct statement. It is actually the advantage of determinate structure. And the last question, okay, the answers are A, B, D and E. Jawapan dia as I mentioned, ada dekat general channel. Saya dah paste since last week. Okay, A, balance cantilever bridges, roof canopy. Single span bridge is actually for simply supported. Okay, the real simply supported structure. Lepas tu apa lagi jawapan dia tadi? F is not the answer. Okay, precast beam and slab ni pun simply supported. Okay, staircase, cantilever, balcony also cantilever. Okay, so let's see the analysis. Okay, I will export this to Excel. Okay, you group apa? Group apa? H kan? Betul group H? G pula.
Ya, betul doktor.
Okay, group H. So this is the attendance for this week. Okay. So before we end session, boleh tak sekejap kita on camera for 2 minutes? Okay, on camera for 2 minutes. Okay. To get the mode. Sekejap, saya nak kena change dekat sini. Okay, together mode. Okay, so thank you for joining this session. Kalau ada soalan lagi, tak faham mana-mana, boleh tanya. Tapi memang kena buat latihan lah, especially solution part tu sebab dia purely mathematic, bukan lagi structure. So purely, once you dah dapat stiffness equation tu, nak solve for the answer, you need to revise back the concept of matrix multiplication. So kalau yang tu clear, means that everything is clear. So I believe you dah boleh follow. So saya monitor from your submission. Okay, from your submission saya dah monitor. Tapi still saya nampak ada lagi yang salin daripada kawan. Okay, ada yang atas salah, tiba-tiba bawah betul. So please try to understand lah sebab this is your as preparation for your test 2. So test 2 boleh cover balik lah insyaAllah test 1 nanti. Okay, so kita take picture 1, 2, 3. So saya letak dekat chat. Okay, another scene sekejap How many of you? 3 and 12. Inilah. Okay, yang ni 1, 2, 3. Okay. Okay, thank you very much. Thank you for participate. InsyaAllah we meet again next week.
Thank you, Doktor.
Okay, Assalamualaikum.
Thank you, Doktor.
warahmatullahi wabarakatuh.
Thank you, Doktor.
Salam, thank you, Doktor.
Salam.